Now we're going to take up one more problem on the shaft, the problem number 32, which reads as find the diameter of the shaft required to transmit 60 kilowatt at 150 RPM. If the maximum torque is 25% more than the mean torque, the maximum permissible shear stress is 60 MPa. Also, find the angle of twist for a length of 4 meters. Take G equals 80 GPa. It is asked in August, September 2020. So first we are going to analyze this problem. So he has given the shaft required to transmit 60 kilowatt. So a capital N will be equal to 60 kilowatt at 150 RPM. So small n will be equal to 150. If the maximum torque is 25% more than the mean torque, so that means T max will be equal to 1.25 times T mean. So find the diameter of the shaft. So D is required to find out. The maximum permissible stress tau max will be equal to 60 MPa, which will be equal to 60 Newton per mm square. Also, so we need to find the angle of twist. So theta we need to find out for a length of 4 meters. So 4 into 10 to the power of 3 mm. And similarly, theta is the one which you need to find out, and capital G will be equal to 80 GPa, which is 80 into 10 to the power of 3 Newton per mm square. So since he has given the power, so first the power transmitted by the shaft, capital N will be equal to 2 pi N into T mean divided by 60,000 kilowatt. So we know the values of capital N and small n. So you substitute that. So that is 60 will be equal to 2 pi into 150 into T mean divided by 60,000. So therefore, T mean will be equal to 60,000 into 60 divided by 2 pi into 150 will be equal to 3819.72 Newton meters. So we have T max will be equal to 1.25 times T mean, which will be equal to 1.25 into 3819.72, which will be equal to 4774.65 Newton meter. So on further simplification, you convert that into meter into mm. So which will be 4774.65 into 10 to the power of 3 Newton mm. Because we want all other dimensions are given in mm square or mm. So naturally this also has to be converted into mm. So once you do that, so consider the torsional equation from the strength criterion. So we have T by Jp, which will be equal to tau by R, which will be equal to G into theta by L. It is a general equation for the torsional equation. So from the strength criterion, we have T by Jp equals tau by R. So substitute the values by torque, which is given 4774.65 into 10 to the power of 3 divided by Jp, that is the polar moment of inertia, which is pi d to the power of 4 by 32, which will be equal to 60 divided by d by 2. So now the diameter of the shaft from the strength criterion, on simplification, you will going to get it as 74 mm. So similarly, from the rigidity criterion, we have T by Jp will be equal to G into theta by L. So again, you substitute the 4774.65 into 10 to the power of 3 divided by Jp, which is pi into 74 by 74 to the power of 4 by 32, which will be equal to 80 into 10 to the power of 3 into theta by 4 into 10 to the power of 3. So therefore, the angle of twist, angle of twist theta will be equal to, so 4774.65 into 10 to the power of 3 into 4 into 10 to the power of 3 into 32 divided by pi into 74 to the power of 4 into 80 into 10 to the power of 3. So on simplification, you will going to get it as 0.0811 radians. So therefore, convert this theta, that is the radians, into degrees. So theta will be equal to 0.0811 into 180 degree pi, 180 degree by pi, which will be equal to 4.65 degrees. So this is how you will be able to analyze and solve this problem. Thank you.